Hi, this is Mithun, and this is video 2 of the Resiliency series. So, in the first video, we checked out what resiliency testing was and what it means to do a bit of resiliency testing, along with the basics of it and how to go about doing it. This video is mainly about the tool that we are going to use to do resiliency testing, how to install it, and how to get started with it, and what the basics are, right, of using that tool. So what do you need to get started with doing resilience testing using Chaos Toolkit? So first you need an OS that supports Python and Python version 3. So right now I'm on Linux and this supports a couple of versions. So the first version that if I just go and type Python version, oops, Python dash dash version is Python 2.7. But for the purposes of Chaos Toolkit, we need Python 3. Fortunately for me, Linux has both of these versions installed, but it comes off with Python 3 here, and it says Python 3.8.2. So we have to use this. Uh, we also have to use something called a virtual environment, which comes sort of inbuilt with Python. uh, you can read about the virtual environments because that's a separate video by itself. But basically, it's like a sandbox where if you install anything and it does not affect the larger system. So it helps you create like different applications with their own dependencies in a separate folder instead of having dependencies scattered throughout the system, which makes a bit of a mess sometimes, right? Because some applications may have a dependency that conflict with another, and the same system will not be able to work with it. So uh, read up on virtual environments, but what we are going to use is the virtual environment that comes along with Python 3. So how do you create one? Uh, s- so the command is simple enough. You basically go and you have this command Python 3 dash m. What kind of virtual environment you need? There are a couple of different types of virtual environments that come in, but with Python 3 you have vn and where you want this to be created. So what I'll do is I'll just say that it has to be created under my under my user directory in a directory called .vns and resilient. That this is going to be the name of my virtual environment. So so since it has created it, let's see if we can actually access it. So accessing it is also simple enough. You basically just have to write source and vns, the name of your virtual environment, bin, and activate. This is going to be the same, just the name of your virtual environment changes based on what you have created here. So once I do this, I have this shows up, right? It says resilient. Now here, I'll just show you something that happens when you have a virtual environment with Python 3. So if I say Python dash dash version, it says 3.8.2. So it has renamed Python 3 to Python because I created it with Python 3, right? Um, so my Python version for this environment or virtual environment is Python 3.8.2. After this, there is another thing called a package manager inside Python. It's called pip, and pip is basically used to install a variety of full applications along with their dependencies. So that's what we are going to use to install Chaos Toolkit. So I'll go and say pip install Chaos Toolkit, right? Inside this environment. So what happens is inside this virtual environment, Chaos Toolkit will be installed, but overall inside the system it won't be unless you go into the environment itself. So you'll find a few of these issues, but that is taken care by the installer itself. So what do we have to do? We have to check if Chaos Toolkit is installed, and it says Chaos is installed and it is version 1.7.0. This is the latest version that's there. So that's it. Your Chaos Toolkit is installed. There are other things in the Chaos Toolkit like drivers. For instance, an AWS driver will help you perform chaos experiments using the AWS infrastructure. Something like WireMock driver will help you perform stuff using the WireMock thing. Uh, right. So the installation is simple enough, and this what can we do after this installation, right? So I have a simple experiment that I've created. I'll tell you what the experiment is, what it looks like. So first I'll have to explain what a chaos toolkit experiment looks like and what the important parts are. So let's get to that. So if I go into like, yes, if I just open the editor of my choice, which is Kite, and I say open, and I go down to like simple experiment. Okay, so this is my experiment. It might be very small. Yeah. So this is the experiment that I'm trying to write, right? So let me explain what the various things are, right? Here, this the first one that you see is basically your version of whatever your experiment is, the title of the experiment, and description of the experiment. So this is like metadata that we'll have to write in order to for it to show up properly in the reports and all the other stuff. The second thing, this steady state hypothesis is basically your steady state hypothesis. In any resiliency experiment, you have to mention what your steady state experiment is. Sorry, steady state hypothesis is. It helps you set a baseline, like saying that, okay, I do anything to the system, but the steady state hypothesis should be met. Like for instance, I can shut down one node of the um, application that I'm testing, but my steady state hypothesis should be met. What could be a steady state hypothesis? It could be that the application is up even though one node is down. The application might have multiple nodes, right? So the application is up even though one node is down. So your steady state hypothesis will be the application is up, and you have to have a probe for that. Now, what are probes? Probes are basically things that so you go and check, right? Let's say if you want to check whether the internet is up or not. So what do? You open up a browser, you go to google.com, and you see if the google.com page is there or not. So that is your steady state hypothesis for your system, whether internet is up or not. You go and check. That check is the probe that you do, right? So here the probe that I'm doing is I'm saying that uh, the HTTP call that I make, right? The URL here, and I do a method called get, it should come to me with a uh, status of 200 and within this time. So this is a probe. Now this may sound a little complicated here, but it's simple enough. Like a probe in the chaos toolkit. So each driver that exposes, now this does not have a driver or anything, but this is just a normal chaos toolkit, the first and the base stuff, right? So that has a probe called HTTP of type HTTP. If you see over here, the provider is of type HTTP. It exposes certain it actually expects certain things from you, right? So when I say I want a probe which is of given by the provider of type HTTP, I have to mention what URL I am going to hit, what the method is going to be. Timeout is optional, and whether I want a tolerance or not. Now tolerance is basically saying that, okay, I have to get this value back. If I don't get this value back, this has failed. So when I hit this URL with a get, I should get 200. Otherwise, this steady state hypothesis is failed. So this is basically a check, like an assertion that we do, right, in test automation, where we check whether certain things are okay or not. Right. So this is a probe. This is how the steady state hypothesis. So this steady state hypothesis, when you start the experiment, it will go and check whether the steady state hypothesis is met or not. Then you can do XYZ things in the experiment. You can actually have actions in the experiment, like shutting down a node, okay, or let's say introducing a network delay or something like that. So in that case, what happens is once a method is created, or once a method is executed, the steady state hypothesis is checked again. And you can have multiple methods where you do all of these things. Inside the method, you can have multiple probes. So the steady state hypothesis is checked at least two times in each experiment. Uh, Assuming you have a very simple experiment, it will be checked once while starting the experiment, and the second time while after the experiment um, action has been executed. So that basically means you start the experiment, the probe will run, saying that okay, is the steady state hypothesis met? If it is not met, the experiment terminates there and then, right? Because there's no steady state experiment, your application is not behaving properly. If the steady state hypothesis is met, then the experiment goes ahead. It has an action that happens. Uh, the action could be anything. Right now over here, uh, my action is very simple. It basically says that go click on this URL or go to this URL and check whether the tolerance is 202 or not. That is my action. That's very simple. I'm not doing anything to the website or so, because this is just a demonstration to show that how Chaos Toolkit works. I'm not doing anything very weird, and I'm using http bin.org, which is basically a third party thing. So I cannot actually go and do anything over there. I can actually, but that I'll show up in the other videos. But yeah, so as I was saying, so your steady state hypothesis is met, and then your action will be done, which is this one. Once this action is done, what I have done inside the method itself, inside my action itself, I have created another probe where I have said that I expect this to be true, right? So once the action is done, it will run this probe. It will check whether this is true, and then it will go back and check whether the steady state hypothesis is met or not. That basically means I perform some action, uh, which was detrimental, so to say, right, to the health of my application, and go and check whether the application recovers or it does not recover, right? So the steady state hypothesis has to be met all the time. Now that is where this thing comes in very it becomes very important in the sense of a resiliency experiment, especially if you're automating it. You have to choose this very carefully. You choose it to be too lax, and then you will not see any valid results. You choose it to be too strict, and even in that case you will see issues that may or may not be there, right? You have to choose something that your application does all the time, even if it has problems or it does not have problems. But when it has serious problems, it has to not meet it, the steady state hypothesis, right? For instance, let's take something like a streaming service, right? In the streaming service, what could be the steady state hypothesis? uh, a streaming service may have multiple microservices around, but what is the main thing that a streaming service has to do? It has to play a video, right? So that will be the steady state hypothesis. It can say that okay, my experiment could be something like this: my recommendation engine is down. Okay, if my recommendation engine is down, my video service should still be able to play a video. Let's say if it's not a recommendation engine, it could be the advertising engine, or let's say the engine that provides you information about the cast and all the other stuff, right? So even if that is down, I should be able to play the video. So what will be your steady state hypothesis in this? The video should always be played, right? So your hypothesis will be that, and your probe will be click on the video and check whether the video plays, right? Assuming that it's a streaming service that we are testing. And what will be your method? Your method will be shut down the recommendation engine. So if you shut down the recommendation engine and you check whether the recommendation engine is stopped over here, and then you can go and check, the experiment will automatically go and check whether the video can be played or not, right? If something goes wrong in the interim, like shutting down the recommendation engine has a cascading failure, and everything goes down and the video cannot be played, then you have a failed resiliency experiment. I uh, that was the simplest thing that I could think of right now. um, so yeah, so this is how it works here. You have methods, you have probes, and there are few other things also on this thing. one of the things that I should tell you is that what kind of providers we have. Like the base one will have a provider called, it will have HTTP, it will have a path and an OS provider. You can use Python scripts to do stuff to your application or to your system, right? So all of these providers are inbuilt, and I have given more information about this in the write-up that I have on our Confluence, right? And yeah, so this is a simple experiment. Let's try to run this experiment and see how it uh, runs. Right. So I'll just go back. Just give me a minute. Okay. So in order to run this, I'll just have to. So I am in the same folder. So I just have to see if this exists where I am. Okay. So simple experiment.json actually exists on my path. So what I have to do after this, I have to type chaos, run, and simple experiment.json. Okay, so what it has done over here. So if you see, it has run, and it says experiment ended with status completed. Okay. Um, so we also have something called rollbacks here. I have not mentioned it in this video, but rollback is basically if you do XYZ things like shutting down a service, or introducing a delay in your network and all the other stuff. So these in some cases are permanent effects, right? Unless you roll back those effects, uh, it will stay, right? So you can have a rollback section where you can undo whatever action you have done at the top. Like if you have shut down a service or shut down a instance, you can just start it back again, right? So uh, it helps it to be truly automated in the sense that you keep the system back to where it was in the previous before you started the experiment. Okay, so rollback has a there are multiple strategies for rollbacks and all, which come in the advanced topics for chaos toolkit, but right now the default strategy is there. And similarly for steady state also, you have a default strategy which is basically running the experiment, uh, checking the steady state, going to the method, and then checking the steady state again. So like you see here, the experiment started over here running the experiment, and I've just mentioned that it is random website testing. It goes, it checks the steady state hypothesis that website is okay. Okay, and the probe is that website must be up, and it says steady state hypothesis is met, basically because it went and checked the website, and it gave a return type of 200. Then playing your experiments method. So this is the actual action that happened, that the website must return 202, and the response should be a JSON, right? And then it goes and it checked all of these things, and it did not find an error. And then it went into website is okay, right? Again, it actually went into the steady state, checked that the website is okay, and the probe returned that it was it was okay. And then the steady state hypothesis was met. Then, because I had not declared any rollbacks here, it basically said no declared rollbacks. Let's move on. So the experiment was completed, right? Uh, Now, if we want to check that, okay, does this thing work? Does it not? And so on. So what I'll do is I'll say 400. Okay. And I've saved it. And I'll try to run this again. Right. So here it tried to run the experiment, and it says critical steady state probe website must be up is not in the given tolerance, so failing this experiment. So it did not even bother to go ahead with the experiment because I had put in a tolerance of 400, which is not right. When once I go to this location, which is, let me just, yes, sorry for that. I should have opened the website beforehand. I go here, right? So this is basically a 200, right? And it is not giving me a 400. because that is what happens when you have a successful URL invocation. So because of that, it failed. Now I can come back. I can change this back to 200 and it will work as expected. But I'll just do one more thing. Is that I will run these. I'll ruin this, not run this. I'll ruin this one and let's see what happens. I'll say 204 instead of 202. Now, how HTTP bin works is that if I say status 204 over here, it will give me a 204 back, right? And if I give a status of 202 over here, it has to give me a status of 202. This is a very good website where when you want to do API testing and all the other things, and it's simple enough, like let me just show it. Just talking about it is okay. Chrome, and you have, oh sorry, I'll have to show this in the developer browser and go to networks. Hit it again. So it says it gives me back a status of 202. Okay, and let's see what JSON it provides back. I'm sure it does. Okay, this is embarrassing. Okay, no issues. Okay, this is not the JSON provider. This is the JSON provider here. Right, so it says this is the JSON that I'm trying to figure out from here, right? So data publication author is yours truly. So that is what I'm checking over here. Like, so this is another one of those providers that are there, and the tolerance is JSON path. So you can actually have very complicated JSON path here as well. So if you want to verify whether an API is up and it is giving the proper thing, so you can have JSON path there, and it says slideshow author, okay, um, and you have to expect that it has failed, right? So slideshow author. All right. So we'll go back to this and I'll do that. Change it to 204 here, right? So let me just run this again. So here you can see. So what happened here was that even though we had mentioned the tolerance of 204 over here, nothing happened, right? That is because any probe that runs inside the method or where the actions are supposed to be, they're only for informational purposes, just to see if everything worked fine after the action was performed and so on. No action is taken on that. Any action that is supposed to be taken is to be taken here, which is where your steady state hypothesis is. Now, the steady state hypothesis runs after each action that you take, right? So you can see over here, right? It basically asks for steady state hypothesis. It did two probes over here, and it would have actually done the calls, taken out the information, but it had not acted on it. So the tolerance that I have given over here is of no use, right? It was different in the previous version, but in this version, that is what the case is. The tolerance is not working out. Over even here, when I say expect failed, it does not work out. So how do you know that it has actually worked and whether the probe was done or not done? So for that, we use something called a verbose mode. So I'll try to run the verbose mode. Let's see what happens. So the verbose mode is basically it will check each and every, or it will log each and everything that it does. So as you can see, it started logging. Okay, so let's go back and see what it has done, right? So if you go here and check, right? So here it is trying to see the steady state thing. So it says succeeded with status 200, right? So then that is what we're expecting in the steady state. You go just a little bit down, it has acted on the first probe that we wanted, must return 202. and the status is 202 and it says succeeded as well. But my tolerance was 204. So there's no control that has been applied on the activity, right? So that basically means we are not doing any check over there about whether it has what whether the tolerance has to be taken or not. Similarly, on the second probe, it has done the call and it has got something here, right? And according to my tolerance, the slideshow.author, which is basically slideshow.author, is yours truly over here, but it should be failed. That is what I expect, right? So that is not happening, and it should have failed. But because no controls are applied, you can basically it basically skips that tolerance part. And the next thing is it goes again after the operations have been done here. It will go again and check the steady state hypothesis. So this is the assertion that actually matters a lot, the steady state hypothesis. This has to be proper all the time, and whatever action you do over here, it's supposed to be a destructive action, and then you go and check what happened to the steady state hypothesis. So that's pretty much the um, a simple experiment, as I said. And unfortunately, this experiment doesn't do much. In the next video, I'll show you an experiment where actually we do something in terms of trying to shake a system out of its uh, steady state and see what happens there. Right. So yeah, so this was a simple experiment running with Chaos Toolkit, and this is how it runs. That was the objective of the video. And in the next video, we'll see something that actually uses some action, some destructive action, to try and do something to a system. Um, I can. I hope that this was informative for you, and see you in the next video. Thank you.